Hello, my name is Ben Ramirez, and today we'll be talking about understanding the fundamental aspects of networks and telecommunications. We'll be citing references from the CISSP All-in-One Exam Guide book from the 6th edition by Sean Harris. So first we'll talk about the International Standards Organization and what they contributed to telecom and internet technologies today. In addition, we'll discuss the OSI and TCP/IP models and how they are different from one another. And then we'll continue with the different IP versions, such as IP4 and 6, comparing and contrasting their features and benefits. And then next we'll dive into Layer 2 security standards and focus on specific network security options. Then finally we'll touch up on the transmission types and wrap up with a summary. So let's talk about the OSI model. The OSI model was released by the ISO in 1984, and it provided the guidelines needed in standardizing communication between different devices across different mediums. So it made sure that different vendors who created different technologies adhere to the same protocol. Now, the TCP/IP model was created earlier, but the OSI's model, or the OSI model's goal, according to Harris, was to create an open architecture providing integration across various technologies. And here we have the various layers within the OSI, such as the application, the presentation, the session, the transport, network, data link, and the physical. Now, it is important to note where each of these protocols that you can see in the parentheses reside in each layer, since certain attacks do rely on specific protocols. But the key takeaway here is that each layer serves one another. In other words, one cannot work without the other in order to transmitting data effectively and efficiently. Let's take a look at the differences between the OSI and the TCP/IP models, as far as just in general what the differences are. So as you can see here, we have 3 more layers in the OSI than its counterpart, the TCP/IP model. But in reality, the TCP/IP model simply combines or renames certain OSI layers. So for instance, you can see here that the application layer in the TCP/IP is really a combination of application, presentation, and session from the OSI, or on the OSI. Host to host is just basically pointing to the transport, so it's just a renaming there. Internet as well, same thing, points to the network. And then we also have the network access layer, which is the bottom layer, and that's also combining the data link and the physical. So I think in summary, the TCP/IP model is really equivalent in certain aspects to the OSI model, as Harris notes. There's no really big difference between these two models, but it's important to know that the renaming conventions here are evident, and you just need to be aware of them. So let's get an idea of the 3-way handshake used in TCP. This negotiation process is very important in order to provide a reliable transmission of data packets, as well as in security. It consists of using synchronous and acknowledgement packets and starts with the initiating device as a SYN. Now, SYN in layman's terms means, hi, I'm a PC in marketing. Here's my request to talk to you. The other device responds with an SYN ACT, which translates to, I received your request. Here's my response that states we can talk now. And the initiating device then receives it, the AC SYN ACT, and then responds back with a ACK, or an ACT, that finally says, thanks, and by the way, here is my data. So during this exchange, we provide negotiation. All communication will be handled in error detection, data flow, and windowing. Now we have to also be aware that there's attacks that exist within this handshake. We have SYN floods that basically send multiple SYN requests to target the device with the goal of using up all TCP connection resources, rendering a denial of service or DOS attack. So solutions to these types of attacks, as Harris suggests, are to implement a SYN proxy. SYN proxy software is going to check for a proper TCP handshake process. So this is a good solution to prevent that. Now we're going to talk about IP addressing and their current versions. We have IP4 and IP6. Now IP4 is still important, and it's still commonly used today. However, their availability is drying up and will soon be depleted. So with IP4, due to the lack of available resources, it must use subnetting. Now, this creates logical partitions for the router in the network in order for network administrators to subnet various departments like corporate or even in a public school system. But as we noted, IP4 is running out, so enter IP version 6. IP6 is the answer to this depletion problem, as well as offering other benefits that come with it. These include IPsec integration and quality of service. Basically, IP6 is moving forward and will provide more space. But it is important that users and network administrators take care of how they configure security applications, because there is something called tunneling, and there are various techniques to do this. These methods are implemented because IP4 is still primarily being used today, and so it allows for IP4 to integrate or blend in with IP version 6 for effective communication between devices speaking in different protocols. So if tunneling is not enabled, security applications will ignore IP version 6 data, therefore possibly allowing an attack to go unnoticed. So we need to make sure that we close the gap so that attackers cannot exploit this weakness. Okay, so now we're going to look at the layer 2 standards in terms of security. Now, layer 2 standards were developed to prevent attackers from performing man-in-the-middle attacks, DOS attacks, or spoofing traffic. The 802.1 AE is an IEEE MAC security standard, or MACsec. This provides a hop-to-hop protection. Using an integrity checksum, the MACsec allows trusted devices to communicate with each other on the network, preventing unauthorized users from coming in. So if a check is validated and good to go, MACsec informs the device to proceed, otherwise it will drop the frames. Now, there are other methods, and they are relatively new and evolving, but what's really important is that network administrators use these standards to prevent unauthorized devices from coming in. So they're really good at preventing attacks like this. And this is an example of a DOS attack that's happening from the attacker, which connects to its masters, which creates slaves, and it goes and it tries to attack one victim. Now we have two types of data transmission. We actually have the analog and digital. Analog is basically using wave values that rely on the amplitude and frequency. Digital uses square waves that are discrete, so basically they're just pulses. The premise here is that digital is the way to go since it is much more reliable than analog. However, there are some systems that still use analog. Eventually, of course, they will probably phase out in the near future. But the reason for this is because digital transmission compared to analog is that analog is prone to noise. We lose reliability at long distances when we use analog, and of course digital is discrete, so it's easier to read. According to Harris in the CISSP All-in-One Exam book, illustration here, we are comparing the two types, and we can see that the digital signal is much more simple, and of course again it's not prone to any kind of interference when compared to the analog signal. And I wanted to also talk about timing. Now, timing of transmissions, we have the asynchronous and synchronous transmissions. This just means that with asynchronous, there is no timing being used, but rather stop and start bit flags to produce understandable messages. Whereas synchronous, we use timing. There is no stop and start bits, but rather a steady timing sequence will be used. Okay, so the bottom line is that security is imperative at all layers of the TCP/IP model. We need to make sure that the network security administrators as well as users are very aware of all the vulnerabilities that happen in all the layers. We also need to make sure that we go deeper into the network to understand where these vulnerabilities are. Technologies continue to evolve, so we need to keep up with these technologies in order to understand where the gaps can exist in terms of security. The complexity increases, and we also increase the risk. So it's very important that we be passionate, and we are always going after those security holes, and that we patch them up, and then we also understand what the attacker is going for. And in order to do that, we have to really understand what the core network looks like, as well as in the telecommunications side of things.